नमस्कार। आज मैले क्लास 8 को साइन्स एन्ड टेक्नोलोजी फोर्स एन्ड मोसन 6.3 प्रेसर लिएर आएको छु। Fill in the blanks with correct words. Atmospheric pressure changes with altitude. Air has mass and occupies space. Liquid maintains its level. Force per unit area is called pressure. Pressure is directly proportional to force and inversely proportional to area. Write any two differences between the following: force and pressure. Force, it is vector quantity. Pressure, it is scalar quantity. Force, its unit is Newton. Pressure, its unit is Pascal. Density and relative density. Density, it is mass per unit volume. It has unit. Relative density, it is the ratio of density of substance to density of pure water at 4 degrees Celsius. It does not have unit. Answer the following questions. What is pressure? Write its formula and unit of measurement. Pressure is the force applied perpendicular to the surface of an object per unit area. Its formula is pressure equals force divided by area, and unit of pressure is Pascal or Newton per square meter. What is atmospheric pressure? How can you measure the atmospheric pressure? Atmospheric pressure is the force exerted by the weight of the air. We measure it using devices called barometers. What is liquid pressure? What are the factors on which liquid pressure depends? The pressure exerted by liquid on the wall of container is called liquid pressure. Factors affecting liquid pressures are height of liquid, density of liquid, acceleration due to gravity. How can you show that pressure increases with the increase of force? The inflated balloon represents a small area like the surface of an object. Now apply force by squeezing the balloon gently with your hands. Observe what happens. As you squeeze, the balloon's diameter decreases. The same amount of air is now confined to a smaller area. This means the pressure inside the balloon increases. Describe an experiment to show that pressure increases with decrease in the area of surface. Experiment: water jet tubes. Materials needed: a tall transparent vessels, 3 short and thin tubes of equal diameters, cork to fit into the tubes, water. Procedure: prepare the vessel, take the tall vessel and insert the 3 tubes into it at different depths from the top. Make sure the tubes are of equal diameters. Seal the tube with cork. Fill with water. Fill the vessel with water up to the top. Remove the corks. Quickly remove all the corks from the tube. Observe the water jet. Observe the water jet coming out of each tube. Observations: the water from uppermost tube travels the shortest distance from the base of the vessels. The water from the middle tube goes a little farther away. The water from the lowermost tube shoots out farthest. Explanation: as the depth of water increases, the pressure of water gradually increases. The greater the depth of a point in a liquid, the greater the pressure. This experiment shows that pressure increases with the surface area decreases. The water comes out with the greatest pressure from the lowermost tube because it has the smallest opening, that is least surface area. Describe in short an experiment that proves occurrence of atmospheric pressure. Fill cleaned empty soda cans with 2 to 3 tablespoons of water. Heat the can in a burner until the water boils. Close the mouth of the container. Quickly pour cold water over the can. Observe as the can crosses due to the low pressure inside compared with outside atmospheric pressure. How can you show that an enclosed liquid exerts pressure in all directions equally? Experiment: balloon, sheet and plastic bottle. Materials needed: a plastic bottle cut in half, a balloon large enough to cover the bottle opening, and water. Procedure: attach the balloon sheet to the cut end of the plastic bottle. Fill the bottle with water. Observe how the balloon bulges outwards due to the pressure exerted by the water. Explanation: the water inside the bottle exerts pressure in all directions, upward, downward and sideways. The balloon bulges because the water pushes against it equally from all directions. This demonstrates that an enclosed liquid, water in this case, exerts pressure uniformly. Prove with an experiment that liquid pressure increases with depth. Experiment: balloon in water. Material needed: a transparent container like a glass or plastic jar, water, a ruler or measuring tape, small balloons preferably clear or light colored. Procedure: fill the transparent container with water. Attach small balloons to the inside of container at different heights. Observe the size of the balloon as they are submerged to different depths. Observations: the balloon near the surface will remain relatively unchanged in size. As you move deeper into the water, the balloon will gradually shrink or compress. The balloons at the bottom will be significantly smaller than those near the surface. Explanation: the pressure exerted by the water increases with depth. This pressure acts equally in all directions. The deeper the balloon is submerged, the greater the water pressure it increases. The pressure compresses the air inside the balloon, making it smaller. Conclusion: the experiment demonstrates that liquid pressure increases with depth. List the properties of liquid pressure. The properties of liquid pressures are: liquid pressure increases with depth. Liquid exerts pressure equally in all directions at the same depth. Liquid maintains its own level. Pressure applied in a liquid enclosed in a closed container transmits pressure equally in all directions. Give reason. It is not possible to drink liquid in space by using a straw. Space itself is a vacuum, which means there is no atmospheric pressure to push the liquid into the straw. The pressure differential that would normally drive the liquid up into the straw is absent. It is easier to cut with a sharp knife than with a blunt knife. A sharp knife cuts more easily than a blunt knife because its narrow edge focuses force on a small area, creating high pressure that slices through materials with less effort. A blunt knife spreads force over a large area, increasing resistance and making cutting harder. A bucket gets filled faster at ground floor than at the top of a house. A bucket fills faster on the ground floor than on the top floor because the water pressure is higher at the ground floor due to high depth, allowing water to flow more quickly. Atmospheric pressure decreases with increment in height. Atmospheric pressure decreases with height because the density of air decreases as altitude increases. At higher altitude, there are fewer air molecules above a given surface, leading to a lower weight of the air column above and thus a lower pressure. Answer the following questions on the basis of given diagram. If the liquid is water, which one is heavier, A or B? A is heavier. Which of them has more density than that of water? A has more density than B. Why does body B float on water? B floats on water because it has less density than water. Solve the following numericals. So in this case we have to find out the pressure. So pressure with one leg it is 40,000 Pascal and pressure with two legs it is 20,000 Pascal. The formula is pressure equals force divided by area. Similarly, a car having its mass 3000 kg occupies an area of 5 square meter and a bus having mass 6000 kg occupies the same area. What is the pressure exerted by them? Use G equals 10 meter per second square. So to calculate this we have to use formula pressure equals force divided by area, and by the calculation force of the car is 30,000 Newton and pressure of car is 6000 Pascal and pressure of bus is 12,000 Pascal. If a force of 3200 Newton exerts pressure of 160 Newton per square meter, find the area on which the force acts. So using formula pressure equals force divided by area and rearranging that into area equals force divided by pressure, we can calculate area equals 20 square meter. Find the weight of a wooden block if it occupies an area of 10 square meter and exerts a pressure of 10,000 Pascal. So we use formula pressure equals force divided by area and we calculate the weight 100,000 newtons. If the depth of water in a well is 10 meter, what is the pressure exerted by it on the bottom of the well? Use G equals 9.8 meter per second square. So using the formula P equals SdG, we calculate pressure 98,000 Pascal. The water column in a tank is 2 meter. Find the pressure exerted by the water on its bottom. So we use the formula P equals to SdG and the pressure is 19,600 pascals. Study the given diagram and calculate the pressure applied by the liquid at the bottom of the container. Use G equals 10 meter per second square. So here we use formula P equals to SdG and calculate pressure equals 18,500 pascals. Thank you so much for watching my channel. If there are any mistakes or any comments, please comment it in the comment box. Thank you.